Good morning, thank you for clicking. I'm Javier and we're going to continue the GID test review. If you have not done so, please like, share, and subscribe. Leave me your comments if you want me to explain to you something more specific. Share the video with your friends so these videos are helpful and more people benefit from them. Today we are going to continue with the GID test because we are not done yet, and we are going to start reviewing counting techniques. We are going to solve this problem, so I'm going to read it for you. A restaurant serves custom-made omelets where guests select meat, cheese, and vegetables to be added to their omelet. There are 6 vegetables available, and guests might select any 2 vegetables for the omelet. How many different combinations of 2 vegetables are possible? Okay, so we are going to combine there, and you will have the formulas available on your test. So let's see. The problem is asking us to, so we need to, this is our problem, and we always have to have clear in our minds what is the problem asking us to solve. So we need to know the what, okay? The what are we looking for and the how, okay? In this case, what are we looking for? We want to know how many combinations of 2 vegetables can we make with 6 vegetables totals, okay? How are we going to do that? Well, there is a formula to combine things in mathematics, and I'm going to write the formula here. So when you are combining the combination of n objects in group of k objects is equal to, and then it's going to be the number of objects in total factorial divided by the objects you will combine at the time factorial multiplied by the subtraction of the total objects minus the objects at the time that you are going to combine factorial, okay? And I'm going to write the formula on the right, and I will explain which thing is, what is what. So C n k comma k is equal to n factorial over, I'm going to have k multiplied by n minus k factorial. So now you know that C is a combination, okay? Combination. N is the number of total objects you will combine. And k is the number of objects that you will combine at a time. Okay, that's the difference. Okay, at a time. Okay, so now that we know what is what, let's use the formula. So let's identify. So we are going to calculate the combination of 6 vegetables in group of 2. That's going to be equal to the total number of vegetables we're going to combine is going to be 6, but that 6 is factorial over, and then the vegetables that we are going to combine at the time is going to be 2 factorial multiplied by the total of vegetables, which is 6, minus the vegetables at the time, which is 2, and that's going to be factorial, okay? We are going to start developing that formula. So combination of 6 objects in group of 2 is going to be equal to, now this parenthesis here, that's going to give me 4, okay? 4, I'm going to write it here, 4 factorial. So I'm going to have here 6 over 6 factorial over this 2 keeps being 2, and 6 minus 2 is going to give me 4 factorial, okay? And I'm multiplying these 2 numbers here. Now I'm gonna cleanse a little bit here, so we use this space. You know the formula already. If you need the formula, you can go back in the video, okay? And I'm gonna continue on the right side, okay? So let's continue there. Okay, so now I'm going to calculate the combination of 6 objects in group of 2. That's going to be equal to 6 factorial keeps being 6 factorial. Oh, let me do it like this. So since we have a 4 factorial at the bottom, I'm going to write 6. 6 factorial is going to be equal to, if I develop this, I'm going to have 6 by 5 by 4 by 3 by 2 by 1. That's 6 factorial, but because I have 4 factorial here, I'm not going to develop everything. I will just write 6 by 5 by 4 factorial, and I'm going to leave it there so I can cancel it out with the factorial I have at the bottom. Okay, so because I have a 4 factorial at the bottom, I'm going to leave that 4 factorial. I'm going to write 2 factorial by 4 factorial. See, and then if I leave it like that, I don't have to multiply everything, and I can cancel these two out. Okay, so the combination of 6 vegetables in group of 2 at a time is going to be equal to, I'm going to have 6 by 5 gives me 30, and 2 factorial is 2 by 1, so that gives me 30 over 2, and that's equal to 15. So option B, as you can see here on the top left of the page, is the right option. So our answer is 15, and you know how we got it. Now if I solve the problem manually, which I'm gonna do it, I'm gonna clean everything here so you know that it's 15 our answer, and I'm gonna solve it manually. Let me clean all of this so we don't confuse the manual procedure with the formula. Okay, so okay, so we know the what and we know the how. Okay, so now I'm gonna calculate it manually. We got 6 vegetables, so I'm gonna draw them here. So we got 6 vegetables. We have 1 vegetable, 2, number 3, number 4, number 5, number 6, and we are gonna combine it in groups of 2. So vegetable number 1, let me do it like this. So vegetable number 1, okay, so vegetable number 1, I'm gonna combine groups of 2. So how many groups of 2 with number 1? How many groups of 2 I'm gonna do? So I'm gonna do 1 group, 2 groups, 3 groups, 4 groups, 5 groups. So number 1 gives me 5 groups. Okay, so now I combined vegetable number 1 with everything else. Now I'm gonna combine vegetable number 2. Because I combined 1 and 2, I'm not gonna combine 2 and 1 because it's the same group. So I'm gonna combine 2 with 3. So I'm gonna combine 2 with 3, with 4, with 5, and 6. So how many groups did I do with number 2? I did 4 groups. Okay, so now I'm gonna do number 3. So number 3, because 1 and 3 are already made and 2 and 3 are already made, I'm not gonna combine 3 with 2 and 1. I'm going to start combining 3 with the numbers on the right. So I'm going to do 1 group, 2 groups, 3 groups. So I got 3 groups. So now let's do it with number 4. How many groups of 4 am I going to make? So I did see 1 and 4 are done, 2 and 4 are done, 3 and 4 are done. So I'm going to combine 4 with 5 and 6. So that's gonna give me, that will give me 2 groups, and just that. And I'm gonna see how many groups I'm gonna do with 5, sorry. So everything else, all of the other groups are formed, so 5 can only be combined by 6 or with 6. So I'm gonna have just 1 group. Okay, so if I add them together, I'm gonna have 5 by 4, that's 9. So I'm gonna have 9, 10, 11, 12. plus 3, this 2 plus 1, that's going to give me a total of 15 groups. 15 groups. Okay, and see, as I'm combining from left to right, I cannot go back from, I mean, if I, yeah, I can, if I combine it if I combine from left to right 1 and 2, when I combine 2, I cannot combine again 2 with 1 because I already have 1 and 2. Okay, so hopefully this helps. Before moving on to the next exercise, I want to show you how to use a calculator to solve this problem. Remember the problem of the combinatory theory? We solved this formula here. We solved 6 combination of 2, and I want to show you how to do that in the calculator. So we are gonna solve this combination in the calculator, and the thing that we are gonna do first, we are gonna put the number of the total of objects we are going to combine, which in this case is 6. Okay, so we are going to put 6 in the calculator, so we press 6. Now after we put the first number, we need to find the function that combines the numbers in the calculator, and that is that key that it says PRB. So we are going to hit that key, and we are going to see 3 options. The first option is for permutation. We are not doing that in this exercise. The second option is combinations. So that's the option we want to use because we need to combine these objects. So we are going to scroll down here in this key that I'm highlighting here, and then when the cursor is on the 2, you are going to hit enter, or you're going to hit not enter, you're going to hit 2 because you're going to select that option. When you hit the 2, so you're going to see the formula on your screen, and then this formula says that you are combining 6 objects, and then you need to tell the calculator how many objects at the time you are combining, and then that number is a 2 because we are combining 6 objects 2 at a time. So we are going to hit the 2 again. Okay, and now we are combining 6 objects in 2 at a time. So we are going to press enter, and that's going to give us the answer, which is 15. Okay, so in that way, that's another way you have to solve the problem during your test, but you need to know what is the total of objects and how many objects you have to combine at a time. Okay, so now, yes, we're going to move on to the next problem. Hopefully this is helpful. Okay, let's solve now this problem about probabilities. The problem says, in a shipment of toys from a manufacturer, the probability that a toy is defective is 1 out of 50. That's why we have this fraction here, 1 out of 50. If Mary selects 2 toys from a shipment, what is the probability that both toys are defective? So now, the problem is not saying if she replaces the toys back or not. If the problem doesn't say anything to you about that, you assume that she picks the toy and she puts it back before she draws the second toy. Okay, because that's going to change the probability of your event. So it doesn't say anything here in the problem, so we are going to assume that she picks the toy, she runs the experiment, and then she puts back the toy, and then she runs the experiment again. Okay, so every time that she picks a toy, she is going to have a probability of 1 over 50 that the toy is defective. Okay, so she runs 2 events. This is the first event. In the first event, the probability is 1 over 50. 1 object is defective out of 50 objects. Now, the problem doesn't say how much is the total, so we are not going to assume the total here. We are going to work just with the probability that the problem gives us. Okay, so now she picks the object in the first experiment, she runs the experiment, and then she puts back the toy in the shipment. Now she runs a second experiment. So if she puts back the toy in the shipment, can you guess what will be the probability that a toy is defective again? Right, so if she puts back the toy in the shipment and then she runs the experiment again, the probability that during the second experiment a toy is defective is going to be the same, 1 over 50, because she put that toy in the first experiment, she put it back. Now, we have here two independent events. That means that because we are replacing the toys, the results are not going to be affected. I mean, the results of the second experiment won't be affected by the results of the first experiment. And these two events are completely independent from each other because they are not affecting each other. So when that happens, the probability that the first toy is defective and the second toy is defective is going to be the product of the two probabilities. So you're going to have 1 over 50 multiplied by 1 over 50. So you multiply the numerators, so you're going to have 1 at the top, 1 by 1 gives you 1. And you're going to multiply the denominator, so 50 by 50 is going to give you 2 over 5,000. And that's why option D is the correct option here, okay?